everyone. Today we are going to discuss the problem alien dictionary. In here the requirement is that we are given a set of values and they can be considered as part of a standard dictionary where we can say that this particular value is comparatively or will come before this value and this value will come before this and so on. So let's discuss. Let's suppose in our current dictionary that we have, the general dictionary that we have, let's suppose there are two values ax and ba. Out of these two values, which one will occur the first, or which one will occur earlier in the dictionary? It is this. How do we know? Because in a dictionary we always compare the characters which are occurring before, and we compare that which one is smaller, and accordingly they are discovered in a dictionary. Now let's consider a string which is a, b, c and r, something like this, and there is a string that is a, r, c, b. Out of these two, which one is smaller? So we know that okay, this and this character is same. Then we will move to the next character. Then we will see that which one of them is smaller. If they're equal, then we will not compare and we will move to the next two characters. And by moving to the next two characters, we will check which one is the smaller one. The moment we discover a smaller one, that will be the moment we will say that yes, this one is the smaller one out of these two. So something similar is given over here as well. It is already given that it is already in a sorted format. That means BAA is smaller than ABCD. Once we say this, that this is smaller, what can we predict out of this? That means this first character is not same. That means B, according to this alien dictionary, B is smaller, or B will occur before A. Fine. Now let's compare the next two characters of the dictionary, that is ABCD and ABCA. Okay, A and A were same, so we move to the next character. B and B were also same, so we move to the next character. C and C is also same. Now D and A got compared, and it is saying that after comparing these two strings, we can still say that this string will occur before in dictionary. That means D is smaller than A. So the next thing that we discovered was D smaller than A. Similarly, we will compare this string and this string, and we will get to know that A will come before C. And once we compare this and this, we will get to know C and C are same, A and A are same. But B will occur before D. So that if B will occur before D, then only we can say that yes, this dictionary is a valid dictionary. So they are saying that this is a valid dictionary. Now tell me, what is the alphabetical order of these four characters that we have? So see, I have written this in the form of the code as well, that this is the current format that they are expecting. So if we know that B will come before A, D will come before A, and so on, can we figure out that what will be the final sequence of the characters of the string? And they are saying that there can be multiple possible scenarios as well. Multiple possible answers can be possible, but give us the valid one. That's all they care about. Okay. So see, we know that okay, B will always occur before A. Okay. D will also occur before A. Fine. A will occur before C and B will occur before D. So this is a kind of graph that we can create out of this dictionary that is given to us, that yes, this will be the current scenario of my alien dictionary, no matter what my sequence is, but I'm sure that something like this is there. B and D are actually smaller than A. It is different than our conventional dictionary, but we do not care about our conventional dictionary because it's an alien dictionary that we are talking about. Fine. Now a task is to tell me that give me the right sequence. When we say right sequence, that means give me the sorted sequence for these four characters. That's where topological sort comes in. If you are aware about this concept, where this concept plays picture is, if there are two characters U and V, and if there is a dependency that before visiting V we should visit U, that's where we use topological sort. we use topological sort to figure out, okay, this is not dependent on any other node, so we can pick up this node, and then we can go to the adjacent nodes and pick them up if they do not belong to any other nodes. That's what topological sort is, and that's what we are going to use now. So if you are aware about the topological sort, it is dependent on upon terminologies like in degree. I would really suggest you guys to go through some videos that I have made in past, but I'll quickly show you the code how we are using topological sort to find the sequence through this diagram, correct? So here, see what I'm doing. This part of code is nothing, but I am trying to figure out, I'm trying to draw the adjacency list or the graph at the end of the day. So you will see that I am picking one string at a time and the other string, and then I'm comparing what is the moment when both of the characters are different. Come out of the while loop and enter inside this if loop, and just make sure that you point your smaller character to your bigger character. You add that value to your adjacency list and you increase the in degree for this value. So see what we have done in this portion of code. We have made sure that we are making an adjacency list. This will be the adjacency list. That means B is occurring before A and D, okay, and D is occurring before A and A is occurring before C. So this is actually my graph. Fine. Now if I talk about in degree, so see, this B is not dependent on anyone, so it's in degree 0. This is not dependent on anyone. There is no internal, sorry, there is one internal node, so the in degree for D will be 1. The in degree for A will be 2 because there are two ingoing edges to it, so it is 2, and for C it will be 1. So these are the in degrees that we know for these particular nodes. So we have done the same thing. As of now, we have found out the in degrees and we have created the graph out of it. Now our goal is to loop over those degrees, those nodes who have 0 in degrees. So what we are doing, we are checking that if the in degree is 0, get those values inside our queue because these are not dependent on any other values. So we'll pick up these values. So I can see that, okay, I can easily pick up B. Okay, I'll try to remove. It might take some time. Okay, let me remove these characters. Okay, fine. So what we are going to do now is, I have created a queue. In my queue, what I'm doing, I am adding all those values whose in degrees are 0. So it is B as of now. So I have added B and I will remove B. Once I'm inside my queue, what I'm doing, I am removing this value from my queue, and I am going through all the adjacent nodes and removing their edges as well. Basically, the A had in degree, that is 2, which was because of these two nodes. But out of these two nodes, I'll remove this node because I have just popped out this element from my queue, and that will let the in degree to reduce to 1. So the in degree is now reduced to 1, but still it is not 0. So we'll not worry about it. Fine. In the next loop, we can see that yes, there was one more node that was connected to this B, so I'll remove this as well. And once I remove this, the in degree will become 0, and at this point I will add this value, this D value, inside my queue. So as of now, the D is added. So if you are seeing, whenever I am popping an element, I am making sure to add this to my answer array. So as of now, my answer is B, but now I have inserted D as well in my answer. And once I'm at this stage, I will remove this value as well. And what I'll do, I will explore all the adjacency values and I'll remove the adjacency links as well. That will lead to decreasing of the in degrees of the connected neighbors. So the in degree at the end of the day will become 0 for this A, and the moment it becomes 0, I'll add it inside my queue. Fine. And I can see that there is no other adjacency node for this D, so I'll stop and I'll go on to my next node, and my queue is still not empty. I still have A. I'll pop out this element, and what will happen, once I pop it out, the adjacency edges will get removed as well. Because of this, the in degree for the C will become 0 as well. The moment it becomes C, I'll add it inside my queue, and I'll pop it out, add it to my string, and I'll see there is no other adjacency values to this C, and I'll stop, and at the end of the day I'll return my answer. So this is what I'm doing. This will be my answer, right? So what I have done, I created a graph out of the connections that I had, and then I used topological sort to figure out that which two characters should come before which. So for this we use topological sort, which use in degree concept, and in degree we pick all the elements who are not dependent on anyone, that is whose degrees are 0. We add them to our queue, and we keep on pushing the elements by removing the subsequent neighboring nodes, and by removing the in degrees. And at the end of the day, once our queue is empty, we come out of the while loop, and we every time when we are popping something out of our queue, we are adding it inside our array as well. So this was a small solution. I will quickly discuss the space and time complexity. So if we talk about the space and time complexity, so this portion of the code is handling is going through each character of our string. In the worst case, first of all, this for loop is going through all the strings, and in the worst case, this while loop can go through all the elements till the very end. So basically, for this portion of the code, the time complexity is the number of characters, that is 5, the number of strings, that is 5, into, or we can say into the average length of the smallest length of the string. So in this case, the smallest length is 3. So as of now, my time complexity is 15. So to simplify this, I can write n into minimum length of my string. Okay, so this was the time complexity just till now. In the queue, what I'm doing, in the queue I'll have combination of I'll have some combination like A to B, B to C, C to D, but these were all equal to the number of command Z, I think yeah. But if you look carefully, this combinations that you will have will always be equal to the number of strings that you have in your dictionary. So these are equal to n combinations that you will have at the end of the day. Okay, and for each combination, our queue is going again and again and adding up the items. So the time complexity for this particular portion will be O of n. So overall, we can say that the time complexity will be equal to O of n into minimum number of minimum number of length of string, and I guess the length of the string that is expected from us is under 50. So yes, we can consider it, we can't ignore it. So we can say n into number of minimum length of the string will be a time complexity. If we talk about this space complexity, so we are using an adjacency list, and this adjacency list is handling all the combinations such that it will be storing this and this, one character from this and one character from this, then one character from this and one character from this, and so on. So we can say that the overall space complexity of this adjacency list will be equal to n. So O of n is the space complexity of this, O of k is the space complexity of this, and we are using a queue as well. In the worst case, all the values can get added to my queue, that is all the elements will be equal to k. So overall, I can say that the space complexity will be O of n plus O of k plus O of k. So overall, it will be O of n plus k will be my space complexity. So that's all. Hope it helped. Thank you so much.